Alright, so in this video we're going to go over the Chapter 9 topics for the cumulative review. Remember, Chapter 9 was about functions, so that's why in these examples here we see some functions. So we have f of x equals 3x plus 5. We've got g of x equals x squared minus 2x. We've got h of x is x minus 5 over 3. Alright, so the first thing, number 10, tells us just to evaluate h of negative 4. So we're using this function here, h. So h of negative 4, we're going to put negative 4 in for x, so negative 4 minus 5, and all over 3. So we've got negative 9 over 3, which equals negative 3. So h of negative 4 is negative 3. Now remember that this little open circle is composition. So what that means is we're going to put one function into the other. So put one into the other. So the order goes, I want g, and I want to take f and put f into g. So f is going to replace x in g of x. So I'm going to take the function g of x, so I need g of f of x, which is 3x plus 5, so 3x plus 5, and put it in to g. So I need 3x plus 5 squared minus 2 times 3x plus 5. I've got to expand this, so I'm going to actually move this over. G of f of x equals, I've got 3x plus 5, 3x plus 5, minus 6x minus 10. Now here I need to FOIL, so I need to do 3x times 3x, I get 9x squared. 3x times 5, I get plus 15x. Now I've got to do 5 times plus 15x again. 5 times 5 plus 25. Now minus 6x minus 10. Combine your like terms. 9x squared doesn't have any, so equals 9x squared. I got 15x, 15x, 6x. So 15, 15, that's 30. 30 minus 6 is 24, so plus 24x. And finally, I've got plus 25 minus, so plus 15. So that is my composition. Alright, and the last one just says, hey, we're taking f plus g of 3. So I need two ways I can do this. I can do f of 3 plus g of 3, or I can add the two. I like to split it and say, what is f of 3? Add it to g of 3. So f of 3. F of 3 is 3 times 3 plus 5. So that's 9 plus 5, which is 14. And I'm going to add whatever g of 3 is. Well, g of 3, that is 3 squared minus 2 times 3. So we got 9 minus 6, which is 3. Add them together, we get 17. We got 9 plus that. Let's see, 3 squared minus 6 plus 3. Alright, and now we have to find inverses. Remember, finding inverses, first we're going to switch out x and y, so 1, or switch out function to change to y equals. Change to y equals. So changing to y equals, we get y equals 13x minus 6. Step 2 is switch x and y. So we get x equals 13y minus 6. And now, step 3, solve for y. Alright, so I need to add 6. Add 6, I get x plus 6 equals 13y. Divide by 13. Divide by 13. I'm going to go y equals x plus 6 over 13. And finally, step 4, change to inverse notation. So remember inverse notation, I had g, so I have g inverse of x equals x plus 6 over 13. So same process. Change it to y equals cube root x minus 6. Note that this is a 3, and that means that I don't have to worry about domain, so no domain issues. Switch x and y, x equals the cube root of y minus 6. If I want to get rid of the cube root, I need to cube both sides. So I've got x cubed equals y minus 6. And finally, add your 6, add your 6. Y equals x cubed plus 6. And lastly, we had h, so h inverse of x equals x cubed plus 6. There we go. Alright, carrying on, we've got a few more examples here. We're talking about domain and range for the following examples. So, the easiest way to do domain and range is just to graph it. So go to your graphing calculator. Remember that you need to clear it out. Absolute value is under math. So we got absolute value, arrow over to number, and hit abs. That's absolute value. I have x in the absolute value, close it out, minus 5. And I'm going to graph that. Now my graph is on a little bit of a funky screen. I'm going to zoom, and I'm going to go back to the standard 10 by 10 grid. There we go, that looks much better. Well, domain is left to right. So remember, domain, we're going left to right. So looking at my calculator, it looks like from the left, I hit everything. So domain, here, negative infinity to infinity. I'm going to hit every x value as I cross this graph. If I kept going, I'm going to imagine arrows on the end here. Range is a little bit different. Range, you start at the bottom and you work your way up. So looking at the graph, the bottom, I have no values down here. So I need to find what that lowest point is. So there's a few ways you can do it. One, you can kind of test around. I see that it's probably at 0. So hit trace, and then hit 0, and if it snaps to that lowest point, you got it. Otherwise, you can go second calculate, like we've been doing some minimums and maximums. Well, that's a minimum point, so you can find the minimum here. Let's go left of it, go right of it, and guess in between. And sure enough, I get 0, negative 5. So the lowest point in my range that's included is negative 5. And then I keep going up the graph. Oops, sorry. I'm going to hit everything above that, so to infinity. Without looking at the graph, you can even just look at the vertex. The vertex of this function is at 0, negative 5. Well, that relates to that. So going to this function, you can say the vertex is 2, 1. I know the lowest or highest point is going to be 2, 1. Well, this opens up, so that's going to be the lowest point. But again, if you go to your y equals, clear out, get our absolute value here. Oops, just need math. We have x minus 2, end, and then add 1 to the end. When I look at that lowest point again, 2, 1 seems to match, and it does. arrow off to the side, so left to right, I hit everything. So domain is everything. In my range, we're going to start at 1 and include it, and we're going to go to infinity. So that's domain and range. Using your calculator is probably the best tool for those. Alright, variation. Well, remember we have a few types. We've got direct. So that's your y equals kx, just one multiplication. Got inverse. That's your y equals k over x. We've got joint. That's your y equals k xy, so multiple going on. And we have a combination of these. Well, this says inversely, so I'm probably going to look like this one here. So if A varies inversely, well, we need K. We need over B. Now we're given what they are, so now let's solve that. A is 6, K we don't know, B is -3. Multiply both sides by -3 to get rid of the -3 on the bottom. So K equals -18. Well, now it's telling me find A when B is 4. Well, I found K now. I can put that into this equation to get A equals -18 over B. And I can use this equation to then find A when B is 4. Well, A is going to equal -9 over 2, since that's how we could reduce that. So we started with a general, we found a K, we got the equation, we used it to find a specific value. Same thing for number 16, except for we're doing joint variation now. So V varies jointly, so I need K as H times H, and the square of R, that's R squared, so times R squared. Alright, so that's the first thing, general equation. Now let's put in some values. 32 equals K times 6 times 3 squared, so 32 equals, so that's 9 times 6, that's 54K. Divide by 54, divide by 54, K equals 32 divided by 54. We get 16 over 27. So now put that in, get a general equation here. We get V equals 16 over 27, H times R squared. And we're going to use that to find specific. Find V when we have an H value of 3 and R of 4. So we got V equals 16 times 3 times 16 all over 27, or V equals, let's see, so we got 16 times 3 times 16 divided by 27, and math fraction, so we can do 28.44 repeating, or 256 over 9. And that's our value for V. And that is the last topic for Chapter 9 that you are responsible for on the cumulative exam.